Greetings everyone. Today we're going to explore graphing with slope-intercept form. All right, so we're still using slope-intercept form. We're dealing with lines, right? But today in this specific video, we are also going to work with isolating y. If you're looking for a video where y is already isolated, please check out my YouTube channel. If you are looking for a different style of graphing, please take a look. Again, we are graphing in slope-intercept form with isolating y. All right, let's start off by identifying our pieces. Don't forget, this is review, that m is the slope, but I personally like to think of it as how I'm moving when I count. The b is the y-intercept. It's where my graph crosses the y-axis, but I like to think of it, this is a me thing, as the beginning of my graph. I want to begin on the y-axis. As always, this is a review. Let's go through our steps. So to start off, you want to, and here's what we're adding in this video. This is what's most important in this video. We're isolating y. We need to isolate y to get it into slope-intercept form first. Then the rest is review. You're going to plot the y-intercept. That means you're going to have a beginning number. It's going to exist as a dot on the y-axis. Step 3, you're going to use the slope to graph more points. And remember, my little rule, I always say 5 or fill. Like if you can graph 5 dots, perfect. If you run out of space, just fill up whatever size graph you have. So remember, your slope, you have to think of it as rise over run. That means go up or down first, and then left or right with whatever numbers you're given. Step 4, you're going to draw a line through the points. As always, you want to connect, and we're going to work on labeling B, and we're going to draw arrows. All right, let's get started with example 1. Step 1, we want to isolate y. So remember, I have multiple videos and we've done multiple lessons on this process, so I'm going to go a little bit quicker. I'm going to start by subtracting 9 to the other side because right now it's positive. Opposites go away, negative y falls down, and I can't actually subtract them, so I just write them. Technically, there's a negative 1 in front, so instead of y times negative 1, I'm going to divide each piece by negative 1. Opposites go away, y falls down. This becomes a negative 1x and a positive 9. Now let's break up the pieces. M is the number in front of x. Let's break the slope into rise and run. The rise is negative 1. The run is 1. And you might be thinking, where'd that come from? Well, any number can be written as a fraction over 1. Or remember my little rhyme, if there is no run, it's 1. Alrighty, let's take a look at the b value. I always like to say b is the beginning. It's the number by itself. So I'm going to begin at positive 9 on the y-axis. It has to be on the y. Okay? Now, make that dot really big or label it b. The next step is to count my slope. So place your pencil on the beginning. We're going to rise negative 1. That means down 1. We're going to run 1. So negative means down, positive means right. Negative means down, positive means right. Negative means down, positive means right. So see how I got my 5 dots? I need at least 5 on this big graph. Connect and draw arrows. Let's try again. On this example, we're going to isolate y. First thing I'm going to do is subtract 3x to the other side. Opposites go away. Negative 4y falls down. I'm going to have 12 minus 3x. Again, if you're struggling with these steps of isolating y, see my other videos. Instead of y times negative 4, because they're next to each other, we're going to divide by negative 4. Opposites go away, y falls down. 12 divided by negative 4 is negative 3. Negative divided by negative is positive. 3 does not divide by 4, so it remains a fraction. Alrighty, let's identify our pieces. Slope is the number in front of x, positive 3/4. That's easy to break up into rise and run. It's going to be a 3 over a 4. B is the number by itself. It's going to become my beginning on the y-axis. So let's go to the y-axis at -3 and draw a big dot. And let's label it B. It's the beginning. Next, we want to count our slope. So from that green dot, we're going to rise +3. That means up 3. Run 4. That means right 4. Let's go again. Rise 3. Run 4. Now, I ran out of space. I'm going to show you the opposite. What if I go down and left? Down 3, right 4. See how it still connects? Down 3, right 4. So I've got 5 dots that make a perfect line. So we connect them and we draw arrows. Example 3 is special. See how there's only one letter? There's only one letter. So if you need to, remember that means the zeros in front of the x. But I'm going to actually recommend that you just graph it. Remember my little shortcut? That means slice the y at -2. This is generic. Slice the y at -2. That's just a me thing. So if I'm going to slice the y-axis at -2, I slice it like the fruit ninja directly through the -2. So this is a special line. Let's identify the parts. My slope of any horizontal line is 0, and I did cross the y-axis at -2. And I'm okay if you leave the rise and run alone on this one. Let's try this special one, same idea. I'm going to slice the x-axis at 4. Slice the x-axis at 4. Straight through, big slice. Hopefully yours is drawn much better than mine. Oh my goodness. All right, let's talk about the parts. It's easier to look at the graph. That's a vertical line. It's almost like I could rise 3, run 0, right? Or I could rise 5, run 0. I don't need that piece of information. What I really care about is that you understand that that slope is undefined. Remember my little shortcut with my little stick figure? I can't walk straight up a wall. So we call it undefined. And same thing for the B. I don't cross the y-axis. There is no beginning y point. So we use a word. Let's try 2 more on our foldable. We're going to draw a line down the equal sign. To isolate y, I'm going to start by adding 1x. It says negative, so we're going to add 1x. So 2y falls down, 6 plus 1x falls down. Instead of y times 2, let's divide every piece by 2. Opposites go away, y falls down. 6 divides by 2 nicely, but 1 does not divide by 2. So we're going to leave it as 1/2 x. Right? Leave it as the fraction it is. Let's identify the parts. The number in front of x is a 1/2 positive. We're going to make the rise and the run. Rise 1, run 2. We split it up. B is the number by itself. It's our beginning. So we're beginning at 3. So let's go to the y-axis. Graph our starting point at 3. Make it really big or label it B, please, so it stands out. From that dot, let's count our slope. We're going to rise 1, run 2. Rise 1, run 2. Rise 1, run 2. Rise 1, run 2. So it's a little slower sloping because it was a fraction, a 1/2. So that's okay. Connect and draw arrows. All right, our last example, I chose this one to make it a little bit different, right? We've got parentheses, so let's deal with that first. 2 times x, 2 times -1. Everything else falls down. Next, instead of minus 2, I'm going to add 2 because I can actually add it. So 2x plus y falls down. Negative 5 plus 2, since they're like terms, is a nice clean negative 3. My last step, instead of positive 2x, let's minus 2x. I'm going to have negative 3 subtract 2x. Let's identify the parts. The number in front of x is my slope, so negative 2. If I break it up, I've got a rise of negative 2. If there is no run, it's 1. Or make it a fraction over 1, right? B, the beginning is negative 3. Let's begin on the y-axis at negative 3. Label it B. Let's count. This means down 2, rise negative 2, run 1. Rise negative 2, run 1. Negative 2, 1. And I'm going to go the other direction. I'm going to go up and left just to finish out that perfect line. Let's connect our dots. Let's draw arrows. And there we go, another perfect line. All right, let's make sure that you check out Google Classroom to see what the task is for this assignment. Let me know if you have any questions. Again, if you need help isolating y, see my other videos. If you need help graphing lines, I have more of those as well. Until next time, have a good one.